So we're going to consider the mapping by elementary periodic functions. So we're now saying, well, what happens if f is periodic? Well, if it has periods, well, let's say if for example, it has period 2 pi, then that basically means that if we've got some region of width 2 pi, then that region is going to get mapped to the same place on the, if this is the z plane, w plane, is going to get mapped to the same part of the w plane, whatever it is, as the next region of width 2 pi, and similarly the next region of width 2 pi. So what we expect is that periodic functions, if they have a real period, will map vertical strips onto somewhere in the w plane. It could be the whole w plane, or it could be the upper half of the w plane. In practice, it tends to be a semi-infinite strip like this. It might not be the actual period, it might be half the period and so on. But basically, you'll end up with strips or semi-infinite strips. An example of a semi-infinite strip would be something like this, which will get mapped to, for example, the upper half plane in the w plane, upper half w plane. Similarly, if you've got a function like this, which is for example, has an imaginary period, then you would expect that we get horizontal strips, because basically the value of the function here, if this has period pi, is the same as the value of the function f at this point here. So we expect that in the end we'll get horizontal strips will get mapped to, or semi-infinite horizontal strips, for example, will get mapped to the upper half of the w plane.